The unit circle, what a wonderful phrase. The unit circle, ain't no algebra craze. It means no forgetting for the rest of calc days. It helps our primary trigonometry. The unit circle.
Hi, I'm Caroline.
And I'm Heba.
And welcome to our presentation on
the unit circle. Wait, Caroline, so what is the unit circle? Isn't it just a circle?
Well, it is a circle, but it's not just any regular circle. This is a special trigonometric circle. It has a radius of 1 that allows us to calculate all 6 trigonometric functions on the interval of 0 to 2 pi, otherwise known as the interval from 0 to 360 degrees.
Well, what's the point of that? Why do we need to know it?
Well, like I said, we will easily be able to calculate any of the 6 trigonometric functions for any angle that appears on the circle. And by knowing just one quadrant, we can save time and decrease the amount of work we need to do for each problem, because we'll know the answer for any quadrant. This is going to be so important as the difficulty of the problems increases, because it'll save you so much time and effort because you'll already have it memorized. So, Heba, why don't you tell us about some points?
Well, these basic points are points that you probably already know, because these points might look familiar because they come from 45-45-90 triangles and 30-60-90 triangles. So on the table, you'll see an angle 30 degrees has a sine of 1/2 and a cosine of radical 3/2. And for angle of 60 degrees, the sine is radical 3/2 and 1/2. So basically they switch. And then for a 45 degree angle, you see radical 2/2 and radical 2/2 for both sine and cosine. So this is for quadrant 1.
Wow, that's so interesting. Tell me more. Are there any patterns on the unit circle?
As a matter of fact, there are. So as I said before, quadrant 1 has those values, and they have the same numerical values for the other 3 quadrants. But it's the signs that are different. So for quadrant 2, you'll see that there is a negative cosine and a positive sine. For quadrant 3, there is a negative sine and negative cosine. And then for quadrant 4, there is a positive cosine and a negative cosine. So the numerical values are the same, it's just the signs of those values that differ between each of the quadrants.
Wow, that's so interesting. Let's go through some examples. Our first example is cosine of 150 degrees. And at first, you may look at that and be like, what? How am I supposed to know? That's not in the first quadrant. But you still know that it forms a 30-degree angle with the x-axis. And instead of being positive, since in the second quadrant, the x value is negative, so the cosine is negative. So really, it's just negative cosine of 30 degrees, which would give us negative square root of 3/2.
Next, we see the example of sine 7 pi over 6. And obviously, that's not in the first quadrant, that's in the third quadrant. And you might be like, what? How am I supposed to know what angle that forms? We know it forms a degree of pi over 6, which is equal to 30 degrees, with the x-axis. And then when you do opposite over hypotenuse, you get negative 1/2 over 1. Because it's in the third quadrant, we know that there is a negative value for sine. And so the answer will be negative 1/2.
Our last example is tangent of 7 pi over 4. And again, you may be looking at that like, what? That's all the way in the fourth quadrant. We have to go all the way around the circle to find that. But really, it's just the angle pi over 4, that negative pi over 4 against the x-axis. And as we know, because the sides of both are its square root of 2/2, the answer for any angle of for any angle that is similar to pi over 4, the tangent will always be 1. We just have to consider what quadrant it's in. Since in quadrant 4, one side is negative, the x value, and then the y value is, since the x value is positive and the y value is negative, we know that our answer would be -1.
So thank you for watching, and we hope that you learn more about the amazing unit circle. Again, I'm Heba,
And I'm Caroline.
and have a great day,
Mu
Mu Alpha Theta.